is like the middle ground of energy storage. It isn't used right away, but it also isn't stored for as long as glucose, or not glucose, excuse me, fats are. So, anyways, the reason starch is so great is because it is literally a giant chain of glucose. This means it serves as a great source of energy, especially immediate energy. This is because it releases more and more energy over time, as each glucose molecule is tediously broken down one at a time. Oh, and one more really important thing about carbs. You may be stressed out by all the different kinds of carbs there are, and you may be struggling to remember what a carb is and what isn't. And if you aren't now, you will definitely be later. Well, a neat thing about carbs, at least some of the sugars, but most of the variety of carbs, is that they almost always end in the suffix OSE. So I'll write that down. Carbs almost always end in OSE. Remember this is really important, because later on, once we start diving into some more complicated other macromolecules, we're going to start working with other names, like just tons of other ones. There's different protein names that are really complicated, others aren't, but there's ones like Titan, and we'll get to all of that later. But for now, we need to look into macromolecule structure a little bit more before we move on. So, we need to look at how they're linked together and what bonds hold them together. Now, this differs for most all of the macromolecules, but there's some pretty significant principles we need to learn about. So, some polymers have a hydrogen group, H, and a hydroxyl group, OH. Big polymers are formed when a hydrogen and a hydroxyl group form a water molecule and release it and link together. So here we have one polymer, right? We can see right here. Here's the polymer part, here's the hydrogen group, and here's the hydroxyl group. So to demonstrate how this bonding happens, I'm going to draw them a little bit smaller. So, here are our two polymers. Now, here's the polymer part, like I said, and here, hydrogen groups, hydroxyl groups. So what happens is, these two molecules meet up, and these two, right here, they're going to form a water molecule using their respective atoms. Then, what happens is that water molecule goes away, and what you're left with is an even bigger polymer, or if it was two monomers before this, then you have your starting polymer. So it would look something like this, down here at the bottom, right here. So, what is this kind of reaction called? Well, because we're losing water molecules in the reaction, it's called dehydration synthesis. Now, this is a really, really important reaction because this is how a lot of polymers are formed. So, there's one other kind of reaction we need to learn about, and this is called hydrolysis. It is essentially the reverse of dehydration synthesis. So, what happens in hydrolysis is you have your polymer that is connected, and a water molecule gets pushed towards it or shot towards it. and then that water molecule is going to break apart the polymer back into either its separate polymers that it was part of beforehand, or into its separate monomers, depending on how large it was. So, now we've covered a lot. We've covered carbs, basic and a little bit more advanced macromolecule structure. So now we're going to move on to our second macromolecule, lipids, fats. Well, mostly fats, but they come in some other varieties. So, as I mentioned earlier, you hear lipids or fats and probably think they can't be necessary. People always talk about not being fat and don't eat fats and things like that. Well, I'm here to show you just how important lipids are and to show you how much people have misused the term fat. Anyway, what are lipids? Lipids make up fats, sterols, and phospholipids. The weird thing about lipids is they don't really have a specific monomer, and thus they kind of don't have a specific polymer. Now, they have multiple different monomers, you could say, for each kind of lipid, which make up large macromolecules, which can be considered polymers. But they aren't as straightforward as the other macromolecules are. For example, fatty acids and glycerol heads make up, I'm going to butcher this, triglycerides, or fats. Anyways, lipids are really important to life for a couple of reasons. One, as I mentioned a ton, they make up fats. So why do I think that fats are important for life? Well, fats, first of all, as I mentioned earlier, serve as a long-term energy storage kind of molecule. So